an integral like this one was on your homework of the 7th week in my math lab, and a few of you asked me to present the solution, so here it is. If I see an integral and don't know how to solve it, I go through the different steps of options I have. So first, do I see something if I stare at it long enough? Can I guess an antiderivative? Not really. Second, is it a rational function such that I can use partial fraction decomposition, break it down and integrate the parts? Rational function, polynomial divided by polynomial? Clearly not. Substitution, what about substitution? That I want to use if the derivative of a part of the function is there as a factor such that it will cancel out. Also not really. So derivative of a cosine will be minus sign with a factor. Derivative of an e function is an e function still with a factor. The 4x will just give me a 4, the 7x will just... No. Substitution is at least not an obvious choice. But we have one more thing that we can do, which is integration by parts. And integration by parts, we had one standard case and one a little bit special case where that can help. Namely, standard case, I have a product, that is good already, where one of the factors antiderivative doesn't bother us, like an e function. The e function antiderivative is an e function again, that won't make it more difficult. And the derivative of the other factor becomes easier. So here that would be minus sign. But in that case, that doesn't really help because I would just get the same thing back again, more or less. But that was the other case where I'm hoping to apply maybe several times integration by parts, and I come back to the same integral on the other side of the equation. So I have this integral is something that I solved plus the same integral minus the same integral. Then I can just bring it back and have several times this integral equals what I had. I repeat, I use integration by parts if I have a product and one factor's antiderivative doesn't bother me and the derivative of the other factor makes it much easier. Or if I apply integration by parts, maybe several times and I come back to what I have. And a very good flag for that to happen is I have a cosine or a sine, because you know its derivatives, it's just going in a circle. So let's do that. I'll choose this as my v and this is as my u prime. Doesn't really matter how you call which one, because we write down u prime and u and v prime in any case. So u prime is copying for x, v is copying cosine 7x. Now its derivative is minus 7 sine 7x. Oops. And the antiderivative of that one, what is the function whose derivative is e to the power of 4x? That's e to the power of 4x, and the 4 comes down, so I have to make up for it, a quarter e to the power of 4x. And now, integration by part, no matter what you called it, it's the two antiderivatives minus the integral other way around, u times v prime. Now I use what I have and just copy. So that is a quarter e to the power of 4x times v is cosine 7x minus integral u a quarter e to the power of 4x times minus 7 sine of 7x dx. Okay, now I can tidy this up a little bit and I'll get e to the power of 4x and a sine. And I do the same thing again, go back to a cosine and we'll be able to shift it around and get our integral. So let's clean. This is just copying a quarter e to the power of 4x times cosine 7x. Maybe for the interest of readability, I add brackets, minus. Now I have minus 7 times a quarter that I can take in front of the integral, so plus 7 divided by 4, integral e to the power of 4x times sine of 7x dx. Okay, this is good. No integrals here anymore. That needs to be solved. Do the same thing again. So now this should be u prime and that should be v. Now u equals a quarter e to the power of, oops, yeah, u prime, e to, u prime is copying, is e to the power of 4x, and the antiderivative is that, same thing as above. And v is now sine of 7x, and v prime is 7 times cosine of 7x. Okay, now I do the same thing again, integration by parts, but first copy this part. Hope I can somehow fit this on my living room board. So cosine 7x plus 7 quarters. And now u times v minus integral of whatever I called it the other way around. So u times v, so then I want to use v prime. And in our case that is a quarter e to the power of 4x times v is sine 7x minus integral a quarter e 4x times v prime, 7 times cosine 7x dx. I make some space and clean this up. Which gives me a quarter e to the power of 4x times cosine 7x plus this part times 7 quarters is 7 divided by 16 e to the power of 4x times sine 7x. And now the integral. Again, I get is 7 quarters out. So I have minus times the factor here. 7 times 7 is 94 divided by 4 times 4 is 16. And the integral is e to the power of 4x times cosine 7x dx. And as promised, we are back to the original one. And that's not a problem now, because now we can shift this on the other side and we have something that's the integral. This and this I want to put together. So we have this thing as the same as just copying cosine 7x plus 7x minus this. So I shifted to the other side of the equation and have plus 94/16 of the same integral. So that is equivalent to 49/16 plus 16/16 is 65 16ths of this integral equals this. So that means, okay, I'll copy that. So here's copied the same equation, it's equivalent with adding 16/16 of the integral plus 94/16 of the integral, so 65/16. And now I can solve for the integral that I actually wanted to have. Let me get new chalk. And I have the integral 7x dx equals 16/65 times this, a quarter e to the power of 4x cosine 7x plus 7/16 e to the power of 4x sine of 7x. And now we can simplify that and get the solution. So, cleaning that up a little bit, this is what we get for the integral. And since it was an indeterminate integral, we do not have upper and lower bounds of the integral, we should write plus